Good morning and good afternoon, everybody. Thank you for joining me today. This is Alonzo Trajan-Moore as part of the VMware Solution Engineering team, and our topic of discussion today is going to be modern application management as part of the broader portfolio of VMware products that is VMware Cloud Management. Now, when we discuss modern applications, our particular focus within modern application management will be enhancing vRealize operations integration with Kubernetes. And so when we talk about modern apps, that's what we're referring to, is this form factor, it's containerized applications or Kubernetes-based applications, where containers and Kubernetes are this vehicle for hosting services and applications that's come into a lot of prevalence today, alongside the commonly used form factor, the virtual machine, which also makes a lot of sense in many use cases. So with that, when we're looking at vRealize operations monitoring Kubernetes and modern app constructs, we really have to think about the use cases, right? From an operational standpoint first. The business would get value from operations having visibility and discussion at the deployment and services level, or that you already have and would like to standardize on a monitoring strategy for your Kubernetes clusters. Maybe a Kubernetes presence that's already in the business or anticipated to be in the business. And then KPIs exist or are desired for the data center operations teams that rely on Kubernetes availability and performance information, requiring things such as inventory and relationships, alerts, dashboards, reports, or troubleshooting and associated metrics that have container and Kubernetes as part of that discussion. All of these use cases are phenomenal for an operational perspective, or maybe applying the enhancement to vRealize operations for your day-to-day. And I'd actually love to hear from everyone out there if we're on the right track in putting our focus as VMware here. As part of your business, is Kubernetes a part of your conversation? From a technical perspective, we have an established visibility into the physical and virtualized space, and your more Kubernetes-style constructs, which are themselves a different ecosystem within the data center. Having faster communication then for your troubleshooting or other reasons between that IT and service provisioning team and the developer and users, or those platform teams in between. So how does our capability of collecting container and Kubernetes metrics play into the broader story, right? In terms of a business initiative, we're trying to incorporate modern infrastructure, modern applications into some kind of project or use case. And that's exactly what we're going to show here with our demonstration. So let's say that we have a deployment of a particularly large application for a production environment. There's a lot of elements that can go into this. And whether we're considering an initial deployment, as this demo shows, or just the ongoing maintenance and monitoring of our services, there are a lot of different components that can play into holistically looking into this use case or project. So as part of this, we're going to see some other elements such as network monitoring, log querying, and in our case, our deployment pipelines. And this being VMware, they're going to be VMware branded. These can be different kinds of platforms and products, right? This is just to note that this is possible with the VMware portfolio holistically, and in some cases, there are a lot of benefits to having the VMware portfolio cohesively too. So let's say that we want to deploy a shopping cart application in this case, and it doesn't have to be a full modernization design. It doesn't have a full modernization design. It's sharing a MySQL virtual machine with other applications, so that cannot be containerized. We're going to leave that in its common form factor. But the front end, the actual e-commerce open cart application is going to be containerized Kubernetes. Well, as part of this, let's see what we might experience in terms of an end user's perspective to the deployment. So let's say I am an end consumer, whether that be a developer or QA, or somebody that's just testing an application and would like a new deployment of it. We can go ahead and actually request the deployment of our application. And we're given, as part of this vending machine experience, a form. Now on the back end, the administrators of this platform can decide what are the fields that we need. Tags, maybe a cost center, an owner, or an application type, maybe an environment, and those can either be typed in or they can be selected from fields. And on the back end, those can indicate certain ways that we're going to deploy this application. From a service delivery perspective, what this means is that you can actually start implementing guardrails and compliance frameworks at deployment time, rather than being an afterthought to deployments. So once we're satisfied with our different fields and we've filled in all of the necessary information, we can go ahead and submit as an end user to kick off that deployment. Now let's see a little bit of the background for how this works. First, we see our pipeline execution. So this is the one that we just set off as an end user. And there's some information about who made the request and some of those input parameters that we gave for the deployment. Now, in addition to that, let's see what this pipeline actually is in terms of how it's built out. A pipeline is just a collection of necessary tasks that can be sequential or parallel as far as a deployment. And so for this particular one, we have our MySQL server as one of the components, the deployment in this case of MySQL, though there could be an existing one already. And we have a VMware template where we've defined how the SQL Server is going to be deployed, as far as networking, as far as sizes, accepted images if those apply, along with different components such as that. If we wanted additional ingest configuration, right, through Salt Stack or Ansible or Puppet, other ways that we could go about implementing that as well. Now, in addition to that, for our OpenCart or front-end application, we have our database authentication. So connecting to that external database that we've deployed in this case, sharing those particular secrets so that we can authenticate and our app can access the database post-deployment. Then we have the actual deployment of our OpenCart application. So here we have essentially our kubectl apply command, right, or a create command for our deployment YAML. Then actually exposing that deployment through a service. So in the same fashion, implementing a Kubernetes action that creates the service exposing our front-end deployment. Right. And now that we know and understand the pipeline's design, let's go ahead and verify, because it looks like our deployment has actually finished, our request. Let's verify that the application is actually operational and functional, and it looks like it is. So we can actually go ahead and click through our application and verify that it is reachable. So now that it's live, our application is live, let's go through and actually monitor some of those different data points that we might need for troubleshooting and for just ongoing checks and KPIs for our application. In our case, we start with actually a log aggregator, log insight. And in this case, we can actually query on our particular host that we've just deployed. We'll check our MySQL application or MySQL virtual machine. And so our log aggregator is collecting logs that in this case provide us information as far as the queries that are being called on our particular SQL virtual machine. So we know that that is functioning properly. Once we are done with actual log checks, what can be done as part of our log process, actually, just before I get ahead of myself, log insight can also be leveraged as a way to create alerts as well as metrics in case there are specific logs that we want to keep track of in vRealize operations. That's actually a fantastic use case for leveraging the integration between Log Insight and VROps. Now, once we start to get to more of our structured data, such as our metrics and properties, that's where we get to vRealize operations. And as part of this demonstration, this presentation, the integration that we have set up with our Kubernetes adapter. So looking first at our Kubernetes adapter, we see a healthy instance and some of those different objects that are being collected through the adapter. Quite a few containers, pods, services, nodes, namespaces, right, replica sets, and so on. So if we look at a more visual view of how everything is laid out, here is our adapter and some of those namespaces that are being identified by the adapter. And here's our OpenCart application with, in this case, our replica set and the services. So here are our pods and our container. Now, when looking at the container's metrics, we see Prometheus as one of our options, and underneath that, Telegraph Exporter, what is feeding Prometheus or presenting to Prometheus those metrics. Within that, we have those metrics such as CPU usage, right? In this case, nanocores. And we see that this application, this particular front-end container, is utilizing these many resources. And we can look at our memory usage in bytes. And some of that file system available information, right, that we can also get from our exporter. We have our Kubernetes ecosystem laid out in our vRealize operations pane. But in addition to that, we have the nodes that this Kubernetes environment lives on top of. And so those nodes can get us a bridged view between our Kubernetes environment and our virtual infrastructure or our vCenter environment. So here we not only get a view of our Kubernetes pods, but we also get a view into our virtual machine and the metrics associated with that hosting of that infrastructure. So we can get, for instance, our CPU demand, as well as for a memory perspective, we can get some of that usage. And we see that we are well within the bounds of what we need for our actual virtual machine configuration. Now, once we've verified that our application resource usage is appropriate, that is appropriately sized, and our logging is functional, the next step is to identify what is the chatter, not just within the application, but also with the external world. And that's where we can get into Network Insight, one of our other tools. This enables us to look at this deployment and gather some information around ingoing and outgoing activity, in this case for our MySQL virtual machine. Now, this ingoing and outgoing activity is information that, in addition to troubleshooting, could, for instance, be communicated to SecOps teams or be considered in terms of firewall rules to provide more granular security strategies, right? To know what's communicating with it and what is communicating with back. So here, some of our ingoing and outgoing traffic we see on that first row is between our database and the virtual machine hosting our front end. That's expected. But then there might be other sources that, in addition to being expected, are unexpected, right? And so it's good to have that comprehensive view into what it is we're actually looking at. So in this case, we'll search by specifically the ports of MySQL and see here some of those traffic patterns. So how do we add these kinds of capabilities into our monitoring strategy? Well, before getting into the technology that can get us there, we need to have a good case for embarking on this journey in the first place. What are the goals that we need to measure? What information do we need to collect to properly measure those goals? All goes towards the questions that need to get answered before building the tools to get those answers. And this is step 0, and it underpins the steps that we're about to see. In a nod back to those use cases we talked about at the beginning of this video, once we've determined that an integration is required to collect our needed information, then we plan the integration. With any kind of integration, I typically like to think about the steps as follows. First, we really need to understand our endpoint landscape. That would be step 1. What is it that you're going to need to monitor? In our case today, for Kubernetes and containers, what do we need to consider? Well, I'll go over this as part of the presentation today. The next step would be to validate our compatible monitoring options. So now that we know what we need to measure, what are the valid ways in which we can actually start to measure and collect? Then we actually configure those integration components. So actually tweaking those particular tools and platforms in such a way that they are compatible to get metrics from point A to point B. And then finally verifying those collection results. We'll be walking through these steps. First, as we mentioned, is understanding our endpoint landscape. So with that, it's understanding what are some of those endpoints that we collect today? What are some of the endpoints that we would like to additionally collect from in the future? And this can include your virtual machines, containers, Kubernetes clusters, virtual desktops, right? If those are relevant to your environment, storage arrays, network switches, public cloud VMs or instances, different elements such as that. What are my different endpoints that we can collect from and should collect from? And once we've identified that subset of the ecosystem relevant to what we need to consume, then we can finish up with step 1. Now, as part of this process, step 1, I know we are discussing today the Kubernetes and container strategy, but I also want to bring attention to just how much other stuff vRealize operations can also import into its collection scheme. And that's not just the out-of-the-box items, right, like your vCenter components, vSAN, NSX, and so on. We have a lot of other different management packs out there, adapters, that can communicate with those other components and collect those metrics through integrations. And so these are just a few of those. It's through, in this case, our true visibility suites. And this lets us see things such as our ServiceNow and our Cisco, Palo Alto networks, Hyper-V, and SAP. So if you need additional networking and monitoring and collection, and you need that to be centralized, simplified through vRealize operations, this can be a great thing to look at to expand those capabilities. Now, specific to Kubernetes and containerization and those endpoints, there are a few different options that are made available depending on where our endpoints sit today. If the endpoints are using, for instance, public cloud managed services, EKS, AKS, GKE, we do support those services and metrics collection as part of our public cloud management packs for GCP, Azure, and AWS. If instead we're leveraging a very VMware-centric way of implementing Kubernetes called vSphere with Tanzu, then that essentially leverages the vSphere infrastructure and your vCenter environment that you know and increases that capability to also support Kubernetes constructs and Kubernetes clusters. We'll see an example of this momentarily if we're going this route. Now in the middle, your upstream Kubernetes, your vanilla Kubernetes, so to speak, that might be running on several different kinds of platforms, or maybe the VMware flavored distribution, Tanzu Kubernetes Grid, or Tanzu Kubernetes Grid Integrated as an alternative. Red Hat OpenShift as another example, or maybe there's an even later stage that we've employed with our Kubernetes journey, And that would be to actually rapidly spin up Tanzu Kubernetes clusters in a way that's guardrailed and so on. And that's where Tanzu Mission Control can come in as an enhancement to this kind of deployment. So depending on where your endpoints might be sitting today, that's going to affect the kind of management packs we decide to use. First, for vSphere with Tanzu, the native vCenter adapter will work. We have an understanding of the inventory and the metrics for those particular objects right out of the box. Second, if we need to enhance our capabilities with more native Kubernetes, upstream Kubernetes structures and clusters, that's where we can start leveraging our management pack for Kubernetes. This approach will be our focus for today in our demo, specifically using Tanzu Kubernetes Grid for distribution. And then there is our public cloud presence that will have its own management packs for supporting those more public cloud managed style Kubernetes options. And these can of course be used in unison together, these management packs. So let's talk through these options starting with our left side. The very VMware-centric approach that is vSphere with Tanzu. This option is VMware's approach to making Kubernetes very operationally friendly for most of the teams that have already leveraged VMware data centers and VMware workflows in the past. Effectively, it takes the enhancements that we've made to the ESXi platform, enhancements to vSphere as far as understanding how to run a Kubernetes environment, a Kubernetes supercluster, so to speak, known as a supervisor cluster. And within this, running Kubernetes clusters that you can provide for your dev teams and your other end users. Now there are several benefits to this approach. One of them is we see the same interface that we're used to with vCenter. So vCenter, here we have our cluster of hosts, and within that we have our Kubernetes cluster. In our sample TKG cluster, we have our control as well as workers. And within that, we see that we can run our different kube control commands, and depending on whether I'm a developer or an SRE, we can have different permissions as far as our actual Kubernetes level and container level actions and objects. So that would be our native vSphere approach to Kubernetes. So how does this get monitored by vRealize operations? Well, when it comes to vRealize operations, with this option, we get a very nice operational view through the vCenter adapter, right? Our out-of-the-box integration. And that gives us the ability to look from vCenter out to its particular clusters and our virtual machines. Along with that, we get a lot of metrics for collection right out of the box. And that can be, for instance, namespace formats, which also includes roles and permissions as well as resource constraints, or it can be from a standpoint of virtual machines and clusters. It's a great option to look at if your operations are very vSphere centric today, but we do have the requirement or see a requirement of supporting Kubernetes constructs. Now there's also the way to have Kubernetes that is just hosted on a vSphere platform, and that's another way to approach Kubernetes adoption as well. And we do have support for this as we see here. We have Tanzu Kubernetes Grid, one of those distributions that we mentioned before, running on top of, in this case, a 5-node cluster. And we see that we can also run those Kubernetes and kube control commands that we're used to, for getting what cluster are we on, and who are we within that cluster as far as permissions, what are some of the nodes associated with this particular cluster, and then some of the namespaces for that particular cluster. So there's typical administrative actions one might take as far as Kubernetes is concerned. So how does our view change if we take this approach of using our Kubernetes distribution on vSphere, but not necessarily that VMware vSphere with Tanzu option? Well, in this case, we see the visibility that's a little different, right? But since it's vSphere hosted, we can still tie the Kubernetes constructs to the virtual machines that they live on. So they can still get a nice end-to-end from your vCenter environment out to the actual pods, containers, and services that still make up infrastructure, still make up data center conversation. They're just a different form factor. Far left is our vCenter, and then we traverse through up to those endpoints. And then lastly, let's say that we have a more generically hosted, and what I mean by that is a general platform that has Kubernetes on top of it. That could be, for instance, a EC2 Amazon instance or a Azure VM, or even just your classic vSphere infrastructure, but we haven't made that link, somewhere that's running Kubernetes on top of it. Well, in that case, we can still integrate by way of our Kubernetes management pack for VROps as well. So we see that we can still get metrics down to the container and pod level in order to effectively, back to the main reason why we might have this integration, get value from operations having this kind of visibility, to answer questions that need to get answered, to meet KPIs and measure KPIs that need to get measured. As far as endpoints, we're going to go with a vSphere hosted Kubernetes environment today, meaning that our Kubernetes clusters will be on vSphere virtual machines. Of the examples we saw, this would be example 2. The distribution, in our case, is going to be TKG or Tanzu Kubernetes Grid. So now that we've identified the endpoints and where they live, we can focus on our collection design for these endpoints. There are several different approaches to collecting from Kubernetes that are supported for vRealize operations. Each has its trade-offs in terms of what metrics can be collected, supported operating systems, and overall level of complexity. In the description of this video, there's a link to our management pack for Kubernetes, and it has in it a link for that VMware doc that goes over different methods that we have to get metrics from the cluster into vRealize operations. For a simple approach starting out, there's an ability to use cAdvisor as a collector to obtain a reduced set of metrics from a Kubernetes cluster. In this particular demo, however, we'll get the metrics we need out of the Kubernetes cluster using Telegraph Exporter. So we're going to need to go this route instead, or we're going to use this route instead because Telegraph Exporter supports more metrics that we need. And we're going to use Prometheus as our supported collector for this. This particular design isn't the simplest out of the ones outlined in the management pack documentation, but it does introduce two very popular open source tools, Prometheus and Telegraph Exporter. Additionally, it gives us a lot of flexibility in terms of metrics that can get collected. For instance, if we decide we needed additional metrics than what Telegraph Exporter provides, we could add additional supported exporters to feed Prometheus, which would then go to vRealize operations. The next few slides will touch a little deeper on validation for this particular design as part of step 2. So the kinds of metrics we need is going to inform our design. Different exporters can present different information, so we need to choose one that will provide us what we need. This list of supported exporters is in the documentation. I determined that Telegraph's metrics will get more than enough of what I need, so we're going to go down this route. Now, since we're using our exporters to provide us with more flexibility with data, we will be using Prometheus as our collector. However, as mentioned, we could instead choose cAdvisor to bypass the need for an exporter and collect Kubernetes metrics directly. Now, we've accomplished a lot already for our design, including 3 key things. We know the metrics that we need and the endpoints that supply them. We know the supported exporters that can obtain those metrics, and then we know our supported collector to work with those exporters. The last 2 validation points are back to vRealize operations territory. And that's the first being the adapter in vRealize operations for Kubernetes, which will interface with our chosen collector. We can validate this pretty quickly by verifying that we've chosen the latest version of our management pack and that we've been following its documentations, which we have been. That last component is going to be validating vRealize operations appliance itself. Our latest management packs for Kubernetes at time of writing is going to require a version of vRealize operations appliance that's 8.5 or greater, which we can see in our interoperability tool, interopmatrix.vmware.com. So now that we've verified our components and decided that our approach is the way to go, it's time to actually configure those components. There is going to be some configuration and some tweaking of configs that needs to be done. This is where it's very important to know or engage someone that knows your actual Kubernetes landscape. Right? And making sure that we have a valid distribution. Some points of consideration here, valid distribution. How are the logical isolations done in your particular environment, such as namespaces, roles, service accounts? Some of those constructs that we'll want to be aware of when giving the exporter, for instance, access to the kubelet API, right? Or Prometheus access to scrape Telegraph. Since there's considering the logical isolation, there's also considering permissions and resource guardrails, right? So as far as actually having an environment that's extremely tight in terms of resource limits, we want to make sure that further deployments into our cluster will be within those limits. Now there is some configuration, some tweaking of configs that needs to be done. This is where it's very important to know or engage someone that first knows your Kubernetes landscape, right? Do we have a valid distribution that we're using? What are some of the logical isolations such as namespaces, right, or permission scope, so roles and service accounts? Some of those constructs that we'll want to be aware of when giving the exporter access to the kubelet API or Prometheus the ability to scrape and access our exporter. Now, there's also the considering of resource guardrails. So if the environment has extremely tight resource limits, we want to make sure that further deployments into our cluster will be within those limits. And lastly, knowing about traffic services, right? So any kind of knowledge around proxies, ingress and egress, node ports, load balancers, and so on is going to be important to understand how it's all going to be connected. Once you have your Kubernetes environment understood, then we have our Telegraph exporter deployment. We can configure this with our knowledge of what's coming in this case, kubelet API metrics, and what's coming out, in this case, metrics meant and formatted for Prometheus collection. Now, in addition to that, Prometheus is going to have to know to scrape from the Telegraph exporter, and that's why we're going to have to give it a job to scrape from this exporter for this reason. For this, the operator of Prometheus is going to need a change in configuration or an update to add that job for scraping. And we'll also need to understand where Prometheus itself is going to be hosted as far as the namespace, what the target namespace is that it's going to be collecting from R, and then knowing the authentication information for Prometheus so that we can later set up the adapter for vRealize operations. Now, specifically vRealize operations, the adapter will be able to connect to Prometheus through this authentication. We'll also have to give it information as far as the Kubernetes cluster, how to access that information. And in addition to that, have a tweak in the appliance itself, the vRealize operations appliance, so that it can understand what to do as far as the Prometheus metrics and how to organize those. Now this information is going to be available as part of our management pack documentation. So here's a look at a sample Kubernetes landscape. And we can see how our components for Telegraph and Prometheus use roles and service accounts, services, among other things that may be created during deployment time, but very well could rely on how the environment's already configured ahead of time. Also, the deployment guide in the documentation has examples that can be adjusted for your own needs as far as YAML configs. We won't be able to go through all of the configuration steps, as this could vary quite a bit depending on your own environments, but it may be worth visiting a little of how the Prometheus and exporter handoff actually gets set up. Now, an exporter collects, formats, and presents metrics, but as mentioned, we still need to tell Prometheus where to find and scrape those metrics. This is done in the form of jobs, and is common practice for Prometheus configuration. We see here two examples, for the node exporter in this case, rather than our Telegraph example, and in this case for Redis, which is a little more advanced case of collecting metrics. Data through these jobs by Prometheus gets organized through labels, and these same labels play into how those metrics get organized in vRealize operations. Here's an example of this, where labels help attribute specific metrics to their proper context. In this case, for instance, the source being Prometheus, the job being our kind of exporter that we're using, and organizational labels as well as their values. Another notable configuration is the adapter itself, which requires authentication into the cluster as well as authentication to Prometheus. One note is that the adapter will use this cluster information to connect to the Kubelet API directly and get inventory data. But metrics collection will still need to go through a more involved channel, such as the design we've described with Prometheus and Telegraph. Once we've set everything up, we can verify our results. And it starts to look something like this. We have our Kubernetes pods and containers, as well as the host that they might be running on, services, sets, namespaces. So that was just a quick example or story of how we might leverage this Kubernetes monitoring capability. So why enhance vRealize operations with Kubernetes? To really expand what visibility we have in order to bridge the gap in terms of understanding and monitoring a Kubernetes environment, which again is also infrastructure, right? It's a mode of infrastructure just like the virtual machine is. It's just different. And so in order to cover that landscape as well, to future-proof the business and be ready for it, if it's not already needed, it's an incredibly important consideration that should happen. From an operational standpoint, why might we consider this kind of capability? Well, specifically based on the monitoring strategy that might be needed for the business. That's all for now. In terms of reviewing the vRealize operations integration with Kubernetes, my name again is Alonso Trejamora, part of the VMware Solution Engineering team as part of the Cloud Management Business Unit. Thank you for joining me today. I know this was a particularly involved session with a lot of moving pieces, so I appreciate your time and your patience and your attention. Thank you.